what we're going to do first is just take 60 seconds for each of you guys to introduce yourselves and your company and what you're doing in private wireless.
Yeah, hi, my name is Johan Bjorklund. I'm the CEO of Betacom. Very nice to be here. I love this facility, love everything that MxD stands for, and we're just so happy to be part of this. So what Betacom does is we've been in telecommunication for about 30 years, and we built a lot of networks for the carriers, the large carriers. We've been in stadiums, big, large hotels, airports, etc. And just like Joe said, we saw this great opportunity in private wireless and really enabling enterprises to bring manufacturing back to America again a couple of years ago. And last year we made the announcement, and we really went into this all steam ahead basically. And we are now building, designing, and operating, staying behind managing these private wireless networks for enterprises in the US. And we're super excited to be here. We see this great growth opportunity.
Hi, good to be here with you all. I'm Glenn Laxdal, the COO with Airspan. We're a technology provider to Betacom, and we are really equally attracted to the private network space. We see it as a large and growing space. In fact, we sort of see we're at the very beginning of a long 10, 15-year ramp in private networks. Private networks brings together the combination of technologies, a strong edge computing platform, a strong radio platform, and then the applications that ride on top of that combined platform. So within the technology mix, we provide the radios. We have developed an advanced expertise in small cell 4G and 5G radio platforms, and it's the 4G and 5G radio platforms that you see throughout the manufacturing facility here. And so that's the role that we play. We're partnering with Betacom to really capitalize on this growth opportunity we see in front of us for the next 10 to 15 years.
Okay, Bob?
I'm Bob Pike. I'm with Intel. I came into Intel 2 years ago in an acquisition. I was the founder of a company called Smart Edge, which is an edge computing platform. But now I'm working in the industrial manufacturing setting, helping with kind of these private networks out in the wild, and how they get manifest in a way that delivers business outcomes. So it's kind of fun. But I enjoyed the MxD tour. If you hadn't done it, it's pretty good. It's very pragmatic.
All right, well, good morning. Welcome to MxD. My name is Tony Del Sesto. I'm the technical fellow here at MxD. MxD is the Digital Manufacturing Institute. We are a not-for-profit public-private partnership with a mission to improve the competitiveness of American manufacturers. And we do that by helping to equip them with the latest tools, cybersecurity, workforce expertise, digital, to really help improve their operations. My role here at the Institute is to demystify all this technology and jargon and methodology around Industry 4.0 and digital manufacturing, and to help teach manufacturers the how to implement that in a way which helps them improve and add value to their operations. And pleasure to be with you here this morning.
Super. Okay, so let's dive in. I guess maybe one of the first things we should talk about is how the industry has come together. It used to be that we couldn't put together the pieces to make a private LTE network work with automation in a factory, but now the pieces are possible to put together. And Johan, I wonder if you can start by telling us how Betacom made this system happen.
Yeah. So it kind of started with the FCC actually opening up the CBRS spectrum, which is 3.5 gigahertz, which is a fantastic spectrum for cellular. It has a really good balance between propagation and capacity. Low band has really good propagation, but the problem is you don't have a lot of capacity there. If you go to millimeter wave, you have a lot of capacity, but you don't have a lot of propagation. So 3.5 gigahertz is actually what's been known internationally as the 5G spectrum. So everywhere in the world, many years ago, that was assigned to be the 5G spectrum. But not in the US. It took us a while to get there, but now we're there as well, which is good. So when that became a reality and we could get access to this spectrum and we could give enterprises access to the spectrum, we just wanted to jump on that and be the conduit to making this happening. Because we realized that for enterprises to really take advantage of this, they needed to go out and they needed to be telecom experts all of a sudden. And our industry has been, I think Glenn would agree with me on this, we've been working together for many years, and the industry has been quite fragmented, serving the large carriers for a long time. And what that means then is that there's a lot of companies providing bits and pieces of an overall solution for the large carriers. So an enterprise, even though they may be very large, it's very hard for them to gain this expertise over a short period of time so that they can deploy and own their own network and then let alone manage their own network. So what we did is we had a lot of expertise in-house already, and we gathered that expertise, and then we added the management component to that to allow enterprises to basically build and own their own private wireless network without adding one single headcount to their overall IT department. So we take care of all of that seamlessly in the back end for them.
Okay. And Glenn, maybe you can explain for us what the network looks like. You know, what is the radio equipment and how does that all work?
Well, the radio equipment actually looks a lot like a Wi-Fi access point. I don't think we have any in the room here, but it's small like yay, and it attaches right up there. It attaches either to the ceiling or to the wall, depending on the propagation pattern that you want. So it's sort of the idea is just like a Wi-Fi access point. It disappears into the wall furniture. And then maybe just in addition to that, there's edge compute capability as well as like a mobile packet core to be able to govern the traffic, assign the IP addresses, govern the traffic that's going on inside the building, and allow a private network to be a private network. And then in addition, what Johan talked about is Betacom comes along and provides the management platform, the NOC, if you will, that those two network elements are communicating to, and then that NOC provides the full degree of visualization into the network and the network traffic and so on that's going on, so you can guarantee a certain level of service for the private network that you're working within. I said Wi-Fi and 4G and 5G. Why do you need 4G and 5G in addition to Wi-Fi? These are not competing technologies. These are complementary technologies in every way. But Wi-Fi is not inherently a mobile technology, and is not inherently a secure technology that you can rely on very high grades of service level agreements. Along comes 4G and 5G, and the reason why 4G and 5G are necessary complements to Wi-Fi is that 4G offers and 5G offers mobility, true mobility. It offers security. It's secure by design. It offers a guaranteed service level agreement because you have guaranteed spectrum that you're operating within. It offers precise geolocation and geo-tracking of the devices as they move through the factory. And then eventually, as we get to 5G, it'll offer very low latency because the edge compute is moved very close to the end user or to the application. And by virtue of that edge compute moving close to the user, close to the application, you have extremely low latencies that you can take advantage of. You put all that together, and that's why 4G and 5G we see that 4G and 5G were at the very beginning of a long build-out cycle in private networks. Just as the last 10 years has been about enterprise Wi-Fi, the next 10 years is going to be about deploying these 4G and 5G networks.
Yeah, very good. Bob, I wonder if you can describe how Intel plays in this process, and where do you find Intel chips throughout this network?
Well, it's kind of both software and silicon. Intel has an extremely large number of developers. We provide a lot of software to the ecosystem. Some of it is kind of provided to different players to use to enhance their platform. But just like in the cloud, where virtualization kind of changed the dynamic of a data center, you know what I mean, drove the cost down, changed how it worked. Really underpinning what's happening at the edge is the virtualization of the edge and costs coming down. When it was appliances in a rack, now that you can put it in a single server, ultimately cost matters, right? So what we're seeing is this how you can do zero trust security, how you can implement virtualization at edge what used to take you 2 racks, you can do in a 3U or 4U box. And quite frankly, that matters because it kind of pulls the cost out of it. And then I think with the likes of Betacom and others trying to make this easy, because think about what happened in the cloud, they made it easy. The easier we make this, it's really cost and easy. So that's kind of, I think I see what's happening now.
Oh, super. Well, all right. Now, Tony, with you, I guess what's newsworthy today is that we have a network that's now working in a manufacturing environment, and other people can look at this and learn on how's it going. I wonder if you can describe from your point of view, how did the network come together? Was it easy for you guys to implement? What did you have to do on top of the radio network to make it all work?
Yeah, certainly. So, our mission is to help manufacturers, and a lot of people don't realize 98% of manufacturers in the United States are small and medium businesses, and a lot of them are thinking, I can't do 5G, right? That's only for the larger companies. But one of the things I can say about the partnership with Betacom is Betacom has made it easy. Right? They're managing the install from start to finish. They're managing the configuration. They're managing the commissioning, the testing, the verification, the subcontractors. So I think one of the important advancements, right, as Bob was saying, is that it doesn't have to be difficult. Companies like Betacom can make this easy for you. It was really just a matter of interfacing with our cybersecurity and IT teams, making sure we had the network configurations both from a WAN and LAN perspective to give them remote access, but at the same time, we control the access internally. So it's really the best of both worlds. We had the ease of installation and the expertise of Betacom, but we still manage access and security within our own system. So I think that was the easy part. If I had to pick one challenge, it was what system do we install? And I think that's where a lot of manufacturers are challenged, because if you think about 5G, right? Low band, mid band, high band, standalone, non-standalone, et cetera, you have all these different flavors, if you will, of 5G. And we landed with a private mid-band system for a couple of reasons. One, it's complementary to the high band system we have in-house. And two, we think it will have a very significant impact because of this ease of installation across the manufacturing community.
Super. Okay, so then that leads me to the next thought, which is, how ready are the technologies that underlie this for wider adoption? Is the technology mature enough to go out to those small mom and pop manufacturing companies and really be deployed widely? And maybe Bob, it's best to start with you, because you're a technology provider. What's the level of maturity and readiness to scale up here?
Well, I would say that, because what I referenced earlier, there now is kind of some of the technology that was used with the carrier is scaled down, to where I'm going to use where you needed 8 cores or 120 cores to run something, you run it on 2, right? So you can run a mobile core in a very small form factor. So the economics of it are getting there. I would say when it comes to multi-access, inclusive of Wi-Fi and 4G, I think we're there. I think 5G is going to need a little bit of time to catch up because of the endpoint cost, but that's kind of the way it works. But no, I think we're there. A lot of it has to do with how well everyone figures out the brownfield friendliness, because you got to put it in an existing environment. And I think I'm seeing the maturity of everyone recognizing that, getting past the security. There's certain people who can say yes, but then there's certain people who can say no. So when you go, and you got to get through the people who can say no. So ops, security organizations. So I'm seeing folks beginning to figure that out. So as the flywheel is beginning to spin, it's still a little slow, but you can see it picking up speed because there's a lot of folks pulling on it.
Okay. Glenn, what are your thoughts about maturity?
It's a great question. So I think that maybe let me take it in a couple of different chunks. One, the first part of the readiness of any private networks, Johan referred to it earlier on, is getting access to spectrum. And I think in the US, the FCC has done a nice job in freeing up this perfect swath of mid-band spectrum right in and around the 3.5 gigahertz spectrum band. It's absolutely perfect for private networks. It's also perfect because the rest of the world has also made available this large swath of 3.5 gigahertz spectrum, which is largely going to be used for private 4G and private 5G networks globally. And that will bring eventually a very large ecosystem. So I would say the second thing I'll say is just if you go back in terms of technology history, every 20 years we go through a pretty significant shift in technology. In the 1960 to 1980 time frame, the computing was very centralized on mainframe computers. Then along came the PC in 1980, and for the next 20 years, the computing was very decentralized using a client-server architecture. You compute in the lowest cost compute engine, which was the PC. Then in the year 2000, along came the cloud. And all of a sudden, there was a new way of doing computing. Why compute on the PC when you can pull that back into a centralized cloud? And Amazon and Microsoft and Oracle and others sort of tore into this massive aggregated cloud-based computing model. And now we're entering a new phase, starting in the 2020 timeframe of edge compute. And now this computing is moving all the way back to the edge. Why? Because of the proliferation of sensors that you see in factories just like this. Sensors everywhere, multiple sensors inside of cars, inside of factories, inside of drones. And you need a new network computing model to be able to take advantage of that and to provide a service to that. So edge, the compute moves from the cloud back to the edge. That's why many large technology companies are very interested in this space. And private networks becomes the tip of the spear for that new way of computing, that new genre of computing for the next 20 years. So now back to the network and readiness, the technology readiness. We're ready from a network perspective in 4G, and the ecosystem is more or less there in 4G, but the application development on top of that is not there in the same way that application development wasn't there for the cloud in the year 2000. It took the next 10 years for the applications to develop on top of that. And companies like Equinix, as an example, emerge into this space with a specialization around building out data centers. There's going to be new specializations that emerge in private networks. Betacom is at the leading edge of that will emerge into the space to build out private networks. And so on the network side, the networks are ready for 4G. The networks are in the process of being developed for 5G. The ecosystem is more or less ready, device ecosystem, I mean, in 4G. In development for 5G. The applications is going to be what the next 10 years is all about, developing those applications that pull the technical capability out of these 4G and 5G networks, and we're at the very beginning of that.
Okay. Johan, would you agree with that on the applications?
I absolutely think so. I think Bob and Glenn framed it really well, and that's exactly what we're seeing working with our customers as well, right? We see that there's a real interest here in moving into this space and using private wireless. We see that 4G is ready. The technology is there. To Glenn's point about application development, this is new for a lot of these companies, right? So that's what we love being at MxD. This is really a great playground, a hub for innovation, right? Where in a non-production environment, innovation teams can come together and innovate and really, further develop this application system, the whole ecosystem around that. It's kind of interesting if you go back a little bit. You think about 4G and how quickly 4G was proliferated in this country. Why? Well, it was because of the iPhone. iPhone came in 2007 and basically killed the 3G networks overnight. It was only one network because AT&T had monopoly for that for 2 years here. Right. But everybody needed a 4G network because of that. Metro PCS was actually the first carrier in the world that rolled out 4G. Braxton Carter is sitting here, was with Metro PCS as CFO at that point in time. But there was such a need because the smartphones were already there, so the demand was there. I think with 5G, it's a little different, right? So the demand is coming in parallel with the development of the devices and the applications, but it's going to take a longer time to build out 5G. So it's going to be a longer build cycle for 5G than what we've seen for 4G because the demand is not the same, but the demand is going to come over time. And I think the real reason for 5G really was for enterprise, for Industry 4.0 and so forth, right? For a lot of data management, automation and so forth, right? And that's why we're really excited to work here together with MxD and our partners Airspan, Intel, Druid is our core company that we announced today as well, and really be at the forefront of making that happen.
Yeah. Glenn, I like your model of every 20 years the pendulum swings, and I think the model of the cloud computing business being developed is a good one to follow now, because the early days of cloud computing, we had some large banks and a few large companies working with Amazon and developing those applications sort of on their own. And those became a platform that eventually became something that every small company in the country could latch onto. And I see that happening again in the edge computing world.
Absolutely.
In fact, Tony, maybe you can comment on this. How do you see that development of applications and devices coming around? Is that something your organization can play a role in?
Oh, absolutely. I mean, it's one of the reasons why we're very excited to have this system here in such an innovative space, because we can go ahead and test a lot of these new applications and devices. I think if you look at this through a manufacturer's lens, the systems are advancing rapidly, and I'm really excited about things like multi-access, edge, because of the low latencies, and it opens up a lot of use cases that manufacturers maybe didn't feel comfortable in the past with other wireless technologies. So yeah, I agree. I think the systems are advancing rapidly. Applications will come. Just looking, again, from a manufacturer's context, the one area in the ecosystem I do think is a bit lagging is more on the client-side devices, especially client-side devices for industrial use, right? If you think about things maybe like industrial tablets, bespoke sensors with 5G built in. So I do think that the client-side equipment has a little bit of catching up to do. But again, as systems roll out, and so I will say I think the systems are a little farther ahead of the client-side ecosystem, but as systems roll out, the equipment will come. And there are things you can do that, as a matter of fact, we'll be experimenting with here at MxD, for instance, is using gateways, where we can take some of our wired equipment and easily convert them to wireless on 5G simply by using some industrial gateways. So we are excited, and we will be working closely with Betacom and the rest of our ecosystem to see what options we can develop for manufacturers here in the near future.
Okay, well that's pretty cool. Well, let's move on to the next question, which is really about, okay, how does this help a company? Let's say, I have a Madden manufacturing company and I want to implement a private network. What business benefits do I get from that? Have you done any work to look at this, Johan? How does it really benefit the
We do. Can I pass that question on to Tony? I think Tony has so many good use cases for the manufacturing, and I would, yeah, absolutely. But I just love for that question to be asked to Tony, if you don't mind.
Yeah, happy to. We could talk all day about this, and for those of you joining me on the tour, be warned. But no, certainly I think if you look at a private system and you look at it from a business perspective, and yeah, we could talk a lot of use cases, but I guess three things that I'll kind of focus in on, which I am very excited about. One is flexibility, right? If you think about a private system and you think about flexibility, factories are dynamic. And as we get more into the digital age, they become more and more dynamic. So for instance, let's say I have a big machine and I just need to move this in my factory. And suddenly now I'm losing signal strength in an area of the factory. I can just move an antenna. I can just put in another radio unit. I mean, it's a private system, right? You have the flexibility to configure the hardware and software. I find that very exciting in a manufacturing context. The other thing that I find very useful for manufacturers is what I call mission critical control. I think on private systems, mission critical control is very attractive because as the manufacturer, you control what traffic is on what network. And the exciting thing about 5G standalone systems, right, is when you start to get into virtual networking. Now I can configure virtual networks for different types of traffic within the factory, right? In factories, not one size fits all. I might have one network I want high bandwidth. I might have one network I have low latency, or one network where I have like really sensitive control equipment and I want no non-critical traffic on that network. Again, you have control. And I think lastly, the thing that's very attractive for manufacturers is when you look at coverage per unit area, for instance, dollars per square meter. I find that these mid-band systems really give you some of the biggest bang for the buck, just in terms of overall coverage. As a matter of fact, in use cases, a lot of our members that are investigating these systems are looking at these mid-band systems just because their cost per area of coverage is very, very attractive, especially in some of the larger facilities or facilities that maybe have some outdoor component to them. Use cases, yeah, we can talk about a lot of use cases. Maybe we reserve that for the tour.
Well, we can talk about a lot of that.
Sure, happy to.
Yeah, I think, Glenn, let's expand on this idea of radio coverage, because I think this is an important point, the difference between Wi-Fi and CBRS radio coverage. There are different power levels and different coverage aspects to it, right?
Yeah, so as we talked about a little bit earlier, 4G and 5G are inherently secure and mobile-oriented technologies. That's why you can drive down, the highway at 80 miles an hour, or in Johan's case, 100 miles an hour, and still have connectivity that hands off from cell site to cell site. Likewise, inside of a building like this, it's inherently a mobile technology. When we walk out of the room from this cell, we can easily hand off to all of the other multiple cells, guaranteeing that you've got an adequate coverage level throughout the factory, and the handoffs are done seamlessly. Wi-Fi does not have that capability. That's why we equate 4G and 5G with private networks. Then my thought process around the capability that we're going for here in Industry 4.0, and maybe just picking up on some of the theme that we just talked about, is automation. It's providing a truly automated workflows, whatever the workflow happens to be. And in many cases, you can think of in a factory today where you've got people that are doing RFID tagging around the factory, or you have people that are walking product from one part of the factory to another part of the factory. All that can be done in an automated way using network-controlled devices, network-controlled infrastructure, where you're writing the application on top of that network-controlled infrastructure, and that application is governing what it is that you want to, whatever workflow it is that you want to automate. You need a wireless network that has mobility, security, precise geo-tracking of the device that you're tracking to enable those automated use cases. And there are a myriad of automated use cases, whether you're talking about smart warehousing, smart manufacturing, oil and gas, mining, transportation. There are a myriad of these use cases, and what will happen is that devices, whatever the device is that you want to be controlling, what will emerge is sensors, 4G and 5G enabled capable sensors will make their way into those devices, and those devices will be controlled by the network that we're creating here, and that's the idea.
Okay. Bob, you probably see more of these use cases than any of us. I wonder if you can describe a few of these and how it's being applied.
Yeah, I would say the mobile worker and the mobile thing is number one, so I think you'll put it on the mark. I would say computer vision-based inspection is number two. I think COVID really kind of, that we were dealing with a decline in trained workers, so inspection helps yields, helps throughput, helps, and then as you lose workers. So, and pulling cables just hassle in some of these facilities. So if you can inspect a weld, you can inspect, I really like the use case out there because those are things that will drive business outcome. It's, to me, those are in inventory, like tracking inventory. You don't have to be super precise. If you can 10 meters, I can find it, because you'd be amazed. I can't find it in these facilities. So it's like, those are the ones that seem to move the needle. I know, now there's some cooler ones, but those are the ones that seem to be delivering business outcomes. I do want to talk about a little bit, one of the things that I think is this IT, OT, CT convergence at the edge is really, the applications, there's cloud native applications we can run at the edge, but the people in the factory are used to running a piece of equipment, right? That they see a certain image of. It isn't that we couldn't layer in a cloud native app, slap it on a edge computing, but it isn't necessarily the app, it's the folks who are managing it that are going, so we have to make it look and feel like they're used to. And there's this battle between IT and OT going on. So there's, I just wanted to flavor that in a little bit, because that's what I'm observing out there. It's still a blocker, right? But those are the use cases and kind of some of the things that, you know, I'm observing in the sites that I'm at.
Johan, you've seen some other ones?
Yeah, I just wanted to add to what Tony said about business critical applications and how private wireless can really add to that. So take a different industry right now. Take that we all that travel a lot are very, very familiar with airports. So to think about airports, to think about the Wi-Fi networks that are there. There's a gazillion Wi-Fi networks. Most of them are closed, but some of them are open. So now you have you know, let's say a Boeing 787 pulling in from Japan, for example. Everybody turns on their phones, right? And a lot of them are going to go Wi-Fi because that's cheaper. So what happens to the capacity of the Wi-Fi network when that happens? It goes down. A lot of the business critical applications at airports, such as, for example, luggage scanning, which is important. For example, you're sitting on an aircraft and you see, if you're in Delta, you have a Delta app, you see that, okay, your luggage is now on your aircraft. Great, good information to know, and I can feel better about it. If those scanners are being run on Wi-Fi, guess what happens? When there's no capacity, they can't scan the luggage. So, and also when it comes to public wireless, it's hard to cover airports because there's a lot of concrete, a lot of moving pieces, zoning rights, entitlements, and so forth. It's very hard to get in there and get that going. So back to also what Tony said, mission critical business applications, as well as the control of having coverage, having capacity where you want it is very important. So we deployed a private wireless network with Dallas-Fort Worth, and we used luggage scanning as a proving example there, right? And we actually improved the turnaround time at the gates for aircraft by 22% because the network was up and running. Luggage scanning worked all the time. So if you control your spectrum, you can control the quality at the end of the day of the business critical applications at the end of that spectrum.
Wow, okay. And I'm sure that translates into billions of dollars for an airline to move planes faster.
It should.
Yeah, it should. Okay. Well, I mean, this is pretty interesting. We're going to open up for questions from the audience pretty soon. So, you know, I'm going to ask just a couple more. But I want to get into some of these specific examples. And Bob, you mentioned sort of video inspections. To me, this is a really interesting one where it seems to me that you might be able to improve the quality of the inspection or the precision of that inspection from a human inspector as well. Is that something that goes along with edge computing?
Yeah, I mean, it's the one thing that, like AI and computer vision, the one thing that, you know, think about, we were talking about how technology, the 20-year thing, I think there's always been this yin and yang between distributed and centralized, because I'm old enough to kind of remember the swing. But part of what's driving this compute at the edge is we have to replace a human's eyes. So camera is kind of like the new data entry.
Yeah.
Right, it really is. It's amazing. That's just going nuts. So inspection of the viscosity of glue, the little simple things like looking at, you know, like buttons on a seat. It's amazing to me, you know, like, or even, you know, like that analog. One of the things we're doing in a factory not far from here is they're just translating all that analog because they can't replace it. It's so expensive, they can't. So translating all these analog to digital is like a big deal. You know what I mean? I'm like, how's that saving you money? And then they went, well, a guy had to go out on a clipboard and look at it, right? So now he doesn't have to look at it. Mm-hmm. So don't over-index on the inspection being, now there is some very finite inspection in the medical world where you can get very precise. But things like welds, like we're definitely doing a lot of that inspection, like we're inside of DOD-like equipment, you know, and you want to inspect, and I'm amazed how many welds are in these things, you know what I mean? And, you know, that's where private networking can help out. So there's so many things to think about, like the other one is, I know this will sound boring, but inspection of packaging coming in, or seeing if something's crushed, calling that out quickly, because that'll miss, because if you don't have it, it looks like it's there, but it's busted, right? Well, if I can inspect and see it's busted, then I can get a replacement and it keeps the line going. I'm going, you gotta be kidding me. Then we're just inspecting crushed boxes, you know what I mean? Or can a forklift get under it? Now, I know these don't sound fancy, but it really is moving the needle on. So those are the kinds of things we're using for camera. Because in the beginning, you want to do stuff that's not necessarily human life involved, but helps move the business process. When eventually we can move toward, things that, a little bit more, let's say, where we really do need the less than 2 millisecond kind of response.
Yeah, Tony, I'd love to hear your thoughts too about this sort of real-time inspection and real-time feedback of the controls and how that improves the working of the factory.
Yeah, I think it's a combination of the vision, but I like what Bob said earlier about people, right? We're about a decade into Industry 4.0, and now, Industry 5.0 is already starting to get coined, and Industry 4.0 kind of forgot about people. And very excited about Industry 5.0 because now it's how do you bring people back into that equation? Well, in factories, people are not static, right? One of the big benefits of 5G is that mobility. So if you think about things like portable digital work instructions as an example, or how do people stay up to date on all this data, all these data feeds that are happening in your factory, how does a person ingest that when they're on the go? There's a lot of discussion in Industry 4.0 about digital twins. Well, if you've got a mobile worker wandering around, how can they monitor that digital twin in real time? I think, and with inspection, vision inspection, that's a lot of data to go transmit, right? So I think that the combinations of the bandwidth, but most importantly, again, the flexibility and the mobility and how that integrates with people in your factory, that's where the big opportunities are going forward. And I think that's where 5G is going to be a key enabler.
Yeah, I think it's really reminiscent of what happened in the cloud computing business as well. You look at, like Elon Musk's first company is a Zip2Go company. They used a combination of automation to take out bad actors, malware, and different things like this, and people monitoring that system. And that was one of the first cases of human-machine sort of integration, which I think is going to be even more important in a physical environment like a factory. So, that's very important. Glenn, let me turn to you because I think you're probably seeing a lot of requests from different sectors and different applications. How do you see the strength of demand growing? Do you see a lot of RFQs coming from different facilities now?
It's actually, I'm going to say, exploded. I think that it's a target-rich environment right now, globally, in private networks. So there is what I think that we need to do, even within the industry, is be super selective and focused in the areas that we're going to be going after, identifying what are the industry verticals that we initially want to be targeting, what are the use cases that we want to be optimizing around, what is the network configurations that we want to be optimizing around, so we can just keep it simple, because there is more opportunities coming in than we can actually manage right now. So what I take from that is that there's a lot of demand, there's a lot of interest, there's a lot of maybe learning that is going on. Everyone is trying to sort of understand this new capability that we can take advantage of, and so we're in those early innings where we're all trying to learn. And I think that the demonstration and capabilities being stood up here, it helps us all, I think, gain a better awareness of where this is going. But I think that it was like the starter's gun went off about 9 months ago and is just starting to accelerate. And that's not just in the US, it's in Europe, it's in Asia, it's in Latin America. There's a lot of opportunities, and I think we're really excited about where this is going to go. To the cloud, 20 years ago, now it's the edge cloud or the edge compute is going to bring on the new applications that we're talking about, starting with very, very simple, basic, straightforward ways of automating workflows that we didn't have before, leading to more device innovation, which we need, more sensor innovation, low-cost chipsets that we can deploy in sensors to be managed by networks like this. So we're at the beginning, but the volume and the interest level is really amplifying pretty fast.
That's great. And Bob, what's your perspective on that? Are you seeing rapid growth right now, and I wonder if you can describe, what kinds of companies are driving the initial wave of this?
Well, industrial manufacturing is the biggest because they get lots of endpoints, lots of things to connect. Transportation. We're just beginning to see a little healthcare. Things where people are sitting in seats, less so, you know what I mean? So you can figure those out. Retail's come back a little bit. I would say it's a POC craziness going on right now.
Yeah.
That's the way I look at it. So I think where we're at in the visit, you ever heard that crossing the chasm thing? I think we're right at the chasm trying to figure out where the money is. And, but I think people are beginning to figure it out, you know what I mean? But what's good is the statistics say we're gonna figure it out when you got this much going on, right? So I think we'll get across the chasm here at some point, and then we'll start to amp up toward lots of deployments with, let's say, large number of endpoints. Right now, my observation is there's not a ton of them that are at volume yet, but it's getting close.
But one of the things we've seen in our research is that some of the large companies are driving initial wave because they're able to develop their own devices, their own application. They can throw a team of people at it. You don't see the mom and pops going into this just yet. Is that an accurate representation of what's happening right now?
Yeah, I think on the MxD side, right, we work with a large cross-section of manufacturers, and the early adopters definitely are the larger manufacturers, and I think that's for a couple of reasons. One, just from a business case perspective, when you've got a lot of area to cover, especially indoor, outdoor area. There's a lot of advantages with 5G, for instance, over Wi-Fi. I would even argue that, trying to manage hundreds of Wi-Fi access points, 5G is just going to be just flat out much lower cost to cover that area. So I think that's one. Two, I think the other larger issue, and I think this is where companies like Betacom can really help, it's more on the people side, it's more on the expertise, right? These larger companies, they have cybersecurity teams and IT teams and OT teams, and they have enough expertise in-house where they can understand it. So it's just quite frankly easier for them to move into the adoption of this. The smaller, as you call mom and pop, or your small and mediums, I think they struggle just more on the expertise and the understanding perspective. But again, that's where I think private, mid-band, unlicensed systems like what Betacom has put into our facility, that I think is going to be a game changer, which is going to open up a much larger segment of the smaller manufacturers.
Great, okay. And Johan, I'll give you the last word on this question. How's the demand going?
Yeah, we're focusing maniacally on three segments: airport airlines, transportation logistics, and then industrial manufacturing, which we're really launching together with MxD here. And we're seeing, if you would have asked me this question at the end of 2021, to Glenn's point, the start gun kind of went off last year. And what I didn't know at that point in time was this going to be a 2022 business or a 2023 business? 2022, people were learning, a lot of POCs and so forth, right? And ask me the same question today, it's definitely a 2022 business. It's exploding. It's more than just POCs. We still see a lot of POCs, a lot of industries are learning. So, and the three large industries that we're in, they're moving at different pace. With, I would say, logistics probably leading the way, followed by manufacturing, and then followed by airports. Airports take a little bit longer because of the complicated ownership structure, safety around airport airline traffic and so forth. You can just imagine that, right? But it's definitely a 2022 business, and it's exploding.
Oh, very good. Okay, so I think we have some time for questions from the audience. Just go ahead and raise your hand if you have something. Or we may have some online as well.
Yeah.
Well, we have one, at least we have one in front here.
So I heard you all talk about the speed and the cost cases for doing a private network. Can you talk about energy consumption and energy efficiency as manufacturers are under more pressure to watch their energy use?
Okay, the question is about energy efficiency and deploying a private network.
It's a great question. And I would say that the energy consumption is when you think, well, let me just step back and talk about philosophically. First of all, energy consumption is really a a network-wide phenomena where all of the focus within a data center today is on the energy efficiency of the compute devices that you're putting in those data centers. And then it's all about power management. Everything in a data center is about power management. Likewise, when you move that compute out to the edge of the network, everything as you distribute that computing out to the edge of the network needs to be about power management. We're also on the radio side moving from, in a very similar way, from large macro cells that have been providing the mobile network connectivity for us for the last 30 years, 2G to 3G to 4G, large macro cells, evolving to a much more distributed edge-based radio infrastructure where the radios are very low power. And relative to Wi-Fi, equivalent to lower power than Wi-Fi, because we take about one radio cell for LTE or 5G for every 4 radio cells for Wi-Fi. And we can continue as we evolve the efficiency of those radios. We're at the very beginning of continuing to evolve the efficiency of those radios to get the power down by half as we move forward. So energy consumption is a big deal. And as we distribute the energy consumption from the centralized clouds to these decentralized edge compute nodes, that's a big factor and a forcing function in moving the compute out to the edge in the first place, as we see this proliferation of devices and use cases and so on.
I think the energy consumption of the network is one thing, but you also save energy in trucks driving around and forklifts and whatever. And Tony, maybe you can talk about this aspect. If you implement a private network over a large campus, can you save on the energy that goes into vehicles and forklifts and people running around and all that?
Well, certainly one of the exciting use cases with 5G, as we talked about, is mobility, the ability to put sensors on mobile equipment. So yeah, if you think about trucks running around your facility, if you think about forklifts running around your facility, you now have a greater ability to track the routing, to track the efficiency. We talked about geolocation as an example. So yeah, it's definitely an enabler to look at all the moving parts in your factory and how to streamline them. And of course, certainly from a cost perspective, but huge energy implications there. If you can, if you think about lean, right, and then the merging of lean with digital with 5G, there's some huge opportunities and energy savings there.
Mm-hmm. Yeah, I heard a story, a guy at ExxonMobil was telling me about an oil field in West Texas where they have these tanks, they pump the oil out of the ground and it goes in a tank. And some poor guy in a pickup truck has to drive 2 hours to go out and check if the tank is full or empty. And clearly automating that saves a lot of carbon in the atmosphere.
Then you think about I think also it's a great question. And if you think about the global supply chains right now, how broken they are, you think about all the manufacturing that we're doing in China, think about the huge the freighters, right, going across the Pacific to come over here. Then the trucks taking those parts, right, and distributing locally, right? So the ability to bring more manufacturing here to the U.S. and shortening those supply chains significantly, I think that in of itself is a huge energy saver as well. So the global supply chains are not only not sustainable because of the way they're composed right now, and us as consumers, we want everything tomorrow. We're used to the Amazon world, right? So that in of itself is not very sustainable, but also the energy waste in them are quite phenomenal as well. So I think we're addressing this problem, I think, from a lot of different angles here.
Mm-hmm. One thing too, remember we're implementing edge computing, so you can take what used to be a multiple appliances, put it in a single appliance, and that, almost everybody has some kind of sustainability program, or you have to pass some kind of gate to say, what are you doing to my energy? I've got to reduce it. So you have these, as you get toward the end of the cycle, you have to show that you're doing that. So there's usually some gate you go through to show that what you're implementing doesn't add. So for the most part, because we're implementing virtualization, we can reduce it if we're thoughtful. And quite frankly, the way the world is today, rightfully so, is driving us to do that in the way we plan this. So I think this is a great opportunity actually to help. And we just have to be thoughtful about it.
Okay. Yes, next question.
Could you comment on security advantages of the proprietary 4G, 5G network, specifically cyber over some of the older
Okay, the question is about security implications of going to 4G and 5G.
Yeah, I can get a start on that one.
Okay.
So, first of all, as we're starting to introduce more IoT devices, right? So we start connecting more and more devices. What 4G and 5G has inherent in security protocol is the authentication of those technologies of devices. So those devices have security technologies that have been in the really as inherent in the technologies as mobility is, like Glenn talked a lot about. So Wi-Fi, for example, doesn't have that. So that allows, because that's a growing threat. Right now, most of the threat is coming, let's say, from the core, but moving forward, as we're adding first millions and then billions of these type of devices, right? We're going to see more and more security threats at the edge as more and more devices are coming on, as we're bringing compute, as we're making logical decisions at the edge. So that is a huge advantage from a cybersecurity perspective that these type of private wireless networks bring to enterprises.
Yeah, I think it was the IMEI and the MZ and then log in, you get more authentication. But I think one thing you can do is you can reduce your blast zone. You can just create these, you don't need, you can create as many networks as you want, and zero trust is kind of the idea. You can build native into edge computing, things like certificate and key management. You can do things that were hard to do in an appliance natively in the box. So this is where the governments are helping us in implementing these kind of things. So there's no, you can make it just, and one thing I caution us in is we got to get to this kind of zero trust, but we can't make it so darn hard nobody wants to use it. So how do we marriage that security with effortlessness? So that's one thing we're kind of working on. But what is true about the protocol is because the carriers didn't want anybody to use it for free, they made it just really prescriptive in how you can use it. So we're just leveraging that standard, right? Then just layer in some other microservices that kind of introduce some new things into it that you can do in an edge computing scenario.
Mm-hmm. I would say, maybe just to amplify a couple of those points, because of the authentication paradigm, 4G and 5G is secure by design. And then you think about what's happening in the market right now with the proliferation of sensors that these networks are going to be authenticating onto the network, hundreds of millions, billions, tens of billions of sensors. The threat canvas explodes. Mm-hmm. And so you need a network that is inherently secure in order to manage that threat canvas. And then to the point that was just raised, we can, within 4G and 5G, minimize the blast zone down to any degree that we want, any isolated level that we want. So that very large threat canvas then becomes a very controlled threat canvas. And nothing, I would say that, as any entity, whether it's an enterprise network or a carrier network that is managing networks today, power consumption is one of the concerns, security is the other of the concerns. It's number one, and we've got to get that one right, and that is why we're seeing such an emergence right now in demand for private networks, because the demand is so clear and the security requirement is so important.
Okay, one more question? Yes, right in front.
So I just wanted to make sure I understood the connectivity picture as it stands today. Is it 4G with a schedule or a roadmap to 5G? And in terms of any other connectivity, is it replacing all connectivity at this site, or is there going to continue to be some Wi-Fi, some hardwired connectivity, anything else?
Sure, I can comment on kind of what we're doing here. So, yeah, I don't think, and I think it was mentioned earlier, that these technologies are mutually exclusive. As a matter of fact, I think a lot of these technologies, when you look at things like Wi-Fi, 4G, 5G, and even within 5G, you look at mid-band versus high band as an example. A lot of these technologies are complementary. So, and here at MxD, remember, we are all about innovation, we're all about testing. So we will have all of those technologies concurrently. We'll have Wi-Fi, but not just standard Wi-Fi. We'll be looking at Wi-Fi 6, Wi-Fi 6E. We have 5G mid-band, 5G high band, and so we will be looking at all of these concurrently. Our plan is to put these through the paces, right? We talked about cybersecurity as an example. MxD, working with the Department of Defense, we are the National Center for Cybersecurity and Manufacturing, and we will be doing a lot of cybersecurity testing on all of these protocols and on the system, so we're very excited about that. But even in practical application within a manufacturer, I do not see these as mutually exclusive. Like for instance, we talk about mid-band versus high-band. I do think mid-band is your biggest bang for your buck in terms of coverage, but I can see going forward where there's hybrid applications, where maybe the majority of your facility is covered by private mid-band, but you have small applications, for instance, for high-band, where you need that ultra-high performance in small areas. So definitely not mutually exclusive.
And then with respect to the order, 4G is where it's at today. The devices are there, the network is there, the ecosystem is continuing to develop, in particular on the sensor side, but everything is ready now to stand those networks up today. 5G is in its formative stages, especially in private networks. It's being rolled out in the network today, and we have 5G on the network side available today. The features and functionality will continue to grow over time. On the device side, it's still developing, and I think that we're, over the next 3 years or so within 5G, that's where we're going to see the development of the 5G ecosystem from a device perspective, from a sensor perspective, and we'll start to see the morphing of these private networks from 4G into 5G, and it'll just happen.
Okay, I guess we're up to the end of our time. We're gonna go on a tour now. So thank you very much to our panel.
Thank you.
That's right. So if you can stick with us a half hour longer, Tony Del Sesto is going to take us on a tour of the factory floor where you can see some of these in action.
And if you don't ask me some very hard questions, I will be very disappointed.